Here, basically, when it comes to this chapter, so this is basically computational thinking and problem solving. So basically, it focuses about data structures and algorithms. Right? So data structures and algorithms, that means how you store data and how you write here. So you can see involves abstraction, decomposition, data modeling. Everything is basically belongs to data structures and the pattern recognition and algorithm design and how to write an algorithm to get data from those data structures and save over data in these data structures. Likewise, how computer think, how computer manage its memory and store data, right? So basically, here in the first one, so it is about sorting and searching. There are three things given. So standard algorithms like bubble sort, insertion sort, and I think selection sort. Yes, binary search is given, but only two sorts are given. So in your syllabus, it's bubble sort. So, but I think it was in chapter 11, and then insertion sort in this chapter. So, can you remember bubble sort? We did this. Can you remember bubble sort?
Yeah.
We did this, right? So, okay. So, just to remind, so I'm using this Word document. Just let me know how we did this. What is the algorithm we have used? Right, let's take a new file. Okay. Bubble sort. And algorithm for bubble sort. So if you can remember, so we have given a list like this. So if this is a list, so how it happens? The first space, what will happen?
It will go through each number and
Mm-hmm.
see if the number after the first one is bigger. If it's bigger, then it'll swap out with the smaller one to give an ascending order.
Right. Okay. Great. So it will compare first two numbers in 23 and 45, and if the left side number is bigger than the right side number, then it will sap. Otherwise, it will not sap. So because this concern
Mm.
about the ascending order, so 23 and 45 will not sap, but 45 and 34 will sap, and 34 will come here, and 45 will go there, and 26 and 45 yes will also sap, and 26 will come here, and 45 will go there, and 45 and 78 will not sap, 78 and 98 will not sap, 98 and 5 will definitely slap because 5 will come here and 98 will go there. 98 and 78 will sap, and 78 will come here. 98 will go there. 98 and 45, then these two will be compared. And 45 will come here, and 98 will go on to the next. And 98 and 98, no need to swap, both are equal. So 98 will be here. So this is the first space, right?
Right. Yeah.
Okay, great. So what about the Python program? So if I write a Python program to solve this, so can you tell me the Python program to do the same? So that is what required in the examination basically.
Uh,
If I take a Python program, can you remember how we did this?
mm,
So how we store this data? What was the data structure we have used to store this data initially? Yes.
uh, uh,
Is it
like
list, tuple, or dictionary?
a list.
It's list. Let's say L1 is these numbers. I can give these numbers in the L1 list. This is L1 list within square brackets. I can give the number. Then the algorithm. So when you write the algorithm, the bubble sort, let's write a function bubble sort, def bubble sort. In bubble sort, I'm going to accept one parameter, that is this list, lst, and then by
Okay.
using the list, I'm going to sort this. Let's say, okay, so let's assign this to another variable if you want. Uh, my list ml equal this lst, and you can say for, or while any you can use, yes, for
Mhm.
can k any item, for item in uh, list, my list, or list lst, whatever, for item in my list. Just what you're going to do, you have to compare the item and the next item.
Yes.
So actually, to control that, I'm going to use in range loop, right? For let's say for k, or item in range, length of the lst -1. Why I gave -1? Because the last item should not be compared with the next item. What will happen
Mhm.
then? If you compare the last item with the next item, what will happen? Right? Last item. Will there be next item to last?
No.
Right side item? No. So then the left side, if left side item is last item, then when it compared with the right side item, it will generate an error. Right?
Right.
Let me give the error, right? Let me give the error and show it to you. So if I compare, let's compare. So when I compare, if I compare like in my list, item, this is the left side item. If it is greater than my list, um, my list item plus one, which is the right side item. So then swap. So then swapping happen. But what happen if I use this? Let me run this. I have done nothing, but let me run this. Bubble sort. Okay. Because I have not given anything. So let's do something. Let's say then swapping can be done using. So in Python, there's a special way to swap, but not in other. Normally to swap, you need extra variable, no? Temporary variable. Can you remember? If you have a
Yeah.
tea glass and coffee, tea and coffee, if I ask you to put whatever the tea container, and use the tea container to put coffee, and put the coffee container to put tea, then you need extra container. So first of all, you have to put one of these tea or coffee to that extra container. So then to make that container empty, then you can put coffee to the empty container, and whatever stored in the extra container, you can put it to the you can put it to the previous container, right? Let me
Right.
show this graphically. Yes, if you cannot remember. Okay, these are the, so swapping happens. Okay, let's say you have two containers
Mhm.
like this, and when you want to swap, you need extra container. You can assume that this ball is there in this container, and
Okay.
let's have another one triangle in this container. Now what you want to put, assume this container is if it is x, and if this is y container, and if this is z container. So before I want to put the circle to y container and triangular to x container. So but same
Okay.
time Python will support the same time simultaneous operations. But the thing is, so normally it's not. Normally in other language it's not, in Pascal, or if you are using Java or some other language it's not. So you have to put this circle to the extra container, then the triangle to the x container, then from the extra container you have to put this to y container. So that's what swapping is. Right? That's why you need extra container is used only for swapping. It's always, it's after swapping it's empty, before swapping also it's empty, right? But Python you have
Right.
special operation. So if you want to swap x and y simultaneously, you go like this. Here to here also you can here to here and here to here simultaneously you can give that. That is in Python special operation. But
Right.
practically in other languages, it's not there, right? Remember both methods are. Then you don't need extra container in Python. But let's do according to the traditional method first. Traditional method is
Uh,
you put this is extra container, that is temp. To temp you put ml the, let's say, right side one, left side one you put this one, and then let's take the right side one ml. Yeah, ml. Uh, okay, just put temp to this one, and then you can reassign this ml item is equal to ml item plus one, just for sapin, and we can say ml now item plus one need the content in the temp container. Okay, this is what the sapin, that is general sapin, but in Python this is also valid. So what is the valid thing? You can do this simultaneously. For an example, you can give item, then comma, item plus one, and then you can make it equal to item plus one, comma, item. So that is a magical thing, but anyway, it is possible in Python. Right?
Right.
Okay, so let's comment the first, second one. Let's comment the first one, keep the first one, first method, and let's run this. Okay, inherit syntax, what I said. If, I miss if, how, wonderful. So if, how come that happened? Anyway, okay, then no errors. Let's bubble sort. So let's bubble sort the L2 or any list. We can give any list basically. My list,
Right.
ml, my list equal, let's give a small list like one simple numbers. I just want to do bubble sort on this. Bubble sort. Then I'll give my list. Okay, now it generate list index out of range. Why? Because it will compare this item even with the right side item, the last item which is 4 with the right side item, but you don't have such.
Yeah.
That's why you have to make it -1. Then save, then run this. But if you use the other loop, you can't stop, no? Because it's accessing each and every item, no? The other loop, you don't have the control basically, because for item in list kila dunno, it will access all the items basically, not the indexes. It will access all the items.
Right.
So then you can't check with the index what is the next item. Likewise, you can't check with the index. So, but if other than, in case if you can maintain this separate counter, separate item indexes, then it's possible. But no need to do two things, because this loop will support that range loop. Right, now let's run the bubble. Let's give the my list. This is my list, and I just want to bubble sort the list. Now no errors. Yeah. The second one, no errors, because we have used -1 here. So you have to understand these things carefully. Right? If not clear, please ask anything. If it is not clear. Clear or not clear?
1 second, sir.
Sorry?
Give me 1 second. I'm going through the code.
Okay.
So could you explain the code line by line with each line's purpose?
Okay, so the first line is define the list. So
Yeah.
this is define the function, right? Function with one parameter, LST. Actually, that is the why we are using function here, because we can use this again and again. So for example, if you have another list like ls, another list, no need to run this code again, because we can call the function. You can say bubble so ls. You can call the function, therefore you no need to run this list, run this again and again. We can give any customized list and you can get it sorted. That's why I define a function with one parameter, right? The parameter is the list. As a
Okay.
parameter, you have to you are going to input list. So if you can run this code just by using this L1. To do that, you have to use bubble sort after the sorting part. You have to use independently bubble sort. Independently, you have to use bubble sort L1. Then it will apply for this L1. Okay.
Right.
Then, so this is actually useless thing. I have used a local variable inside the function to this store this LST, but you can directly apply this to LST too. Right? So here actually I have used ML, but that is really not necessary. I can apply from LST. This parameter itself will support to use it in anywhere, but this is something extra that is actually not required, right? ඒ වෙනුවට
Right.
LST දාගෙන ගියා නම් මේ ML තියෙන තැන් වලට it will work. If you put LST
Okay.
instead of this ML, that will work. That is extra thing. But just for some transparency, I have used this ML because ML is belongs to the function as a variable. LST is the parameter. To
Right.
distinguish parameter from the local variable, I have just used that, right? Okay, then for item in range, the L1. So this one you can understand. So this is just
Yeah.
for loop. So length of the ML will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ML minus 1 will be 9. So then it will count indexes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will go to the last item, isn't it?
Yeah.
So then it's wrong now. I want to stop here, but it will go for the last item. Can you remember the in range loop? For k in range for print k. So it will go from 0 to 3. Right?
Yeah.
It will not go from 0 to 4. So that will be applicable here also. No? If I give length is 10, 10 minus 1 is 9, but it will go from 1 to 0 to 8. Understood?
Mhm. Yeah.
So loop will reduce again another one, right? So minus one will
Right.
reduce the count to now. This will like k in range 9 because length is 10. 10 minus 1 is length is 10. So length is 10. 10 minus 1 is 9. But the loop will go up to 8 only. Yeah. 0 to
Mhm.
8. So no
Yeah.
worries. Then it will compare 0th item. So here this is 0th item with item plus 1, the first item. Next round it will compare first item with second item. Next round, second with third, third with fourth, fourth with fifth, fifth with sixth, sixth with seventh, seventh with eighth, eighth with ninth. Because here it will be 8. So here will be 8, but 8 plus 1 will be applied here, 8 with 9. But after that, this loop will terminate because ninth with 10th, no comparison such as, because it will go only up to 8. Understood?
Yeah.
If it is not clear, please ask, right? If it is not clear, please ask. But if you give
Yeah.
9 here, so if you give length here, what will happen? If you give length here directly, it will go up to 10. That means 0 to 9. 0 to 9 means valid. Here to here. 0 to 9th index. 0th index. First 1, 2, 3, 4, 5, 6, 7, 8, 9th index. Because first one will be 0 and this one will be 9. That will be okay. But here what will happen? When it comes to 9th index, 9 plus 1 will be 10th index. Do you have 10th index here?
No.
No, you don't have. That's why you get the error. That's why you give -1 here. Okay, then the second part. Second part I explained already. So that is this, right? So
Yeah.
what was not clear? Is it okay? Or
No, it's okay.
right? So why did you ask that line by line? So I think it's clear to you, no? So anything?
Yeah, now it's
Any reason? Just to confirm.
yeah.
Right. Right. Okay. This is only the first round, right? This is only the first round. I can print line by line, so round by round. So step by step, I can print this by printing the L1. But this is not bubble sort. This is half of the bubble sort, the first half. If I run this, let's run the file, run module. You can see, okay, this is the phases. This is actually the first round, right? Here you can see 23 up here, 23, 43 compared, not set. 34, 26 compared, sorry, 34, 45 compared, no set. 45 and 26 compared, there's a set. This is the set. Then 45 and 78 compared, no set. 78, 98 compared, no set. 98 and 5 compared, then is there a set or no set? 98 and 5?
There is.
Yes,
No.
that is this set. 98 and 5 set. And then you have to compare 98, 78. Is there a set? 98, 78. Is there a set?
Yes.
Yes, there is this set. Then 98 and 45 compared. Is there a set?
Yes.
There is this set. How many swaps are there in this list? How many swaps are there in the first round?
4.
45, 26 will be compared. There is this set. Right? This will be compared and set. That is this one. Then this will be compared and set. That is this one. This will be compared and set. There is this one. This will be compared and set. There is this one. Altogether, how many swaps?
4.
Yes, 4 or 5.
All right.
What about this? Yeah, wait. So when there's a when there's a comparison, you have to swap.
Yeah.
Wait, 4 or 5. That's what I'm thinking. Wait,
It's
24. This one no swap. There's a swap. So this one I couldn't mention. 34, 45. There should be swap, no? See this original list.
34.
See the original list. So don't look at this one. See the original list. Original list.
Right.
The 34, 45. There's a swap, no?
Yes.
That swap will come here. So I didn't mention that. Sorry. Right.
All right.
So that is also a swap. That swap will come here. Got it?
Yes.
Right. Originally there are 5 swaps there. It's not 4, right?
Yeah.
Right. So this is actually 5 swaps, right? Please, I understand that. Right?
Yeah.
So because with the initial swap. So if you consider this one, yes, it's 4. Right. Then this is first round. How many rounds you need to sort this? How many rounds you need to apply? recursively. Yes. Can you sort within one round or cannot?
No,
Hmm?
you can't.
Can't. Then how many rounds you need?
Mm,
Yes. How many rounds you need?
4 more rounds.
Sorry, I didn't get you.
Oh, 4.
4. So how you exactly said 4 rounds? That's that's something to concern. Yes. How you
I
exactly said it's 4 rounds, 4 or 5 rounds? How?
I I guessed that.
You guessed right. Okay. So rather than guessing, so what should be the maximum? What is the maximum? In case if you in the worst case, that means think that list is sorted the other way. List is sorted in descending way. Then you have to sort it in ascending way. In that case, the worst case scenario, you need to do this at least for n minus 1. That n is the number of items minus 1 rounds. Got it?
Right. Yeah.
That is in worst case. So this case, yes, it can be 4 or 5 rounds. This case, it can be 4 or 5 rounds. But in the worst case, it can be go to n minus 1 rounds. So therefore, I'm going to reapply this again and again for n minus 1 rounds using this loop for, let's say, rounds rounds in range. I'm telling again the same thing, length of this one minus 1, this much of rounds. I have to reapply the algorithm this from this much of rounds to get this sorted. After each round, I'm going to print a new line, right? After each
Yeah.
line, each round, I'm going to print a new line just to identify whether this is working. Then I'm going to rerun this. Okay, now you can see the rounds. Right? First, first phase, how many steps? 5 steps. Second phase, how many steps? Yes, second phase in the second round, how many steps?
Um,
First phase, 5. 1, 2, 3, 4, 5 steps. The second place, second phase,
oh, 3.
3 steps. Yes, it's 3 steps. That's why 3 lines are coming here. Stepping is here. You print 3 times here. When there's a step, you print it. So means 3 steps. So then next round, how many steps? You
2.
can identify this, right? So making ඕනම් පුළුවන්. මෙතන තියෙන එකේදී first round එකේදී මේ swap එක වෙනව නෙමෙයි. This is one step. 34,
Right.
26 should be step. This is the first step. Then the next thing is here, this one. 78 and 5 should be step. That is the second step. Next thing is here, 45 and 78 must be step. That is the third step. Understood?
Yeah.
Then the third round.
Yes.
When third round comes, here 45 and 5 should be step here. 45, 5 step. 45 and 5 step. That is the first swap. The second swap is this 78 and 45 here. It's swapped. That is the second swap. Okay, 2 swaps in the third round. Then go to the fourth round.
Yeah.
Fourth round here. You can see 34 and 5 will be swapped. That is one swap. That is third round. Then 26 and 5 will be swapped. That is one swap in the fourth round. In the fifth round, 23 and 5 will be swapped. So you need 6 rounds, no? Your
Yeah.
prediction was wrong. Right. Okay. So
Yeah.
you need 6 rounds. So, but anyway, so if I give this code in the book without explaining this from the beginning, I close this part and no printing statements. All printing statements are comments. After that, what you have is only returning function return the sorted list. Only this return in function. Then let's save this. Assume that all others are blank. Then let's run this. When you run this, right? When you run the bubble sort, so let's print the list first. So I have print here, print L1. And then after this, I'm going to print this one. Right, then in case, let's run this. Okay, let's run this. And now you can see list is this, sorted list is, so I can print like this one. Original list is this, and the sorted list is this. Original list is this, and sorted list is this. Let's run this. You can see without the intermediate step, original list and sorted list. The algorithm is bubble sort. So if I give a note like this, bubble sort algorithm, the code, and then the sorted list. Can we understand?
Yeah.
Now you can understand. If I initially gave this,
No.
so that's why this step-by-step process is always required, right? So anyway, you can optimize this. Right? This is not the best thing. Optimize this. If there are no SAPs, you can terminate. Because you are going here 1 round, 2 round, another 4 rounds. After these 6 rounds, another 3 rounds you are going in unnecessary way, because that is not required. Already sorted list. You no need to try to sort this again. How to eliminate this?
Yeah.
You can make a counter. You can make a counter like this. You can make this counter. Yes, the counter variable. Just make it 0. But when you are swapping, let's make counter equal counter plus 1, just to see the swap counts. Right? Let's print the count in each round. Let's print the count in each round. Counter. So let's run this. Now you can see the original list. Oh, what has happened? I have to print counter here. Just after counter equal counter plus 1, and I have to print the same counter here. Okay, let's make it 0 here, right? Sorry, invalid syntax. I have to make counter after printing the count. I have to make it 0, right? Like this. After printing, let's make it 0. Let's try it now. Oh, local variable counter reference before assignment. Let's make this initially also this, and inside this I can make global counter, but that is not required. Let's see. Okay, now we can see. First round 5 counters, second round 3, then 2 steps, 1 step, 1 step, 1 step, 0 steps, 0 steps, 0 steps. If there are 0 steps, why we repeat that round? That is unnecessary, no?
Yeah.
Right. So then what you can do by using this counter variable, what you can do, you can say if counter equals 0, then break. Because no need to redo this. With this, I can optimize the loop,
Yeah.
optimize the sort. Now you can see it's Oof, oof, ooh. That's not sorted. Sorry. Is it sorted? I don't think. No, no. So here I have to be careful when you're using this. I have to be careful. You see. So okay, now you can see. Now it is optimized. If zero, if zero occurrences, if zero steps, then it will break. So it has cut down two extra steps. Understood?
Yeah.
It has cut down two extra because before making this zero, I have to check, right? Because if I make this zero initially, what will every after making it zero, if I break after each round, it's making zero. Understood? Because in the within the
Yeah.
round, it count and increase. After the round, it will make zero anyway because we have to recount. I'm checking after assigning this zero, then add in one by one, and if it is not come to this swapping pace, then automatically it will be initial zero. If it is initial zero, then I'm going to break. So in that case, if no swaps, it will break. Right?
Yeah.
So
Yeah.
I can make it like more meaningful. Rounds I can make here. Print. These are not required. You can just to understand I'm adding round comma rounds plus one. Then here counter number of swaps. So then this will be like kind of meaningful. Okay. Round one, 5 swaps. Just say like this. Round one, 5 swaps. Round two, 3 swaps. Round three, 2 swaps. Sorry, round three, 2 swaps. Round four, 1 swaps. Round five, 1 swap. Round six, 1 swap. And round seven, 0 swaps. So stopped. Right?
Yes.
So now this is more meaningful. So now I think you can write down this, right? Print. So now you can just try this, right? So because I just want to make it more
Yeah.
meaningful, otherwise, like let's will be nice. Okay, right. Maybe take a print screen if it is lengthier to write. Take a print screen, and later you can try. What do you prefer, taking print
Okay.
screen or trying this? Trying this will take more time because you may commit errors and
Uh. Yeah.
okay. Take a print screen.
Sir, is today's class 4 hours or 2 hours, sir?
Not 2 hours because I'm having some meeting.
Oh.
So next this week another 2 hours I can do in Friday.
Oh, okay.
Friday or I can even do 4 hours in Friday. That doesn't matter. Friday I can do
Oh.
whatever. So tell me what you prefer, then I can do according. That's Friday. So maybe the next week onward, let's put this to the regular schedule. Right?
Yeah.
Otherwise, you will also have some activities and also get some. And it's maybe I can put in. So my plan is to put this in. Uh, yeah, Wednesday evening 4 hours, or Wednesday 2 hours, Friday
Mm,
2 hours. What do you prefer?
Wednesday to yeah, okay.
Will be better, no? Wednesday 2 hours, Friday 2 hours.
Yeah.
Uh, I'll do like that. Wednesday evening. Let's put in the evening.
Sir, give me one moment. My father is calling.
Okay. Next thing is we are going to learn about the next type of sort in the book, which is insertion sort. Actually, these are like very small things, right? In your book, maybe it's like few lines, but the thing is to explain, and it will take some time, right? But algorithm is anyway given. The algorithm is anyway given. So here it's given using, I think, Pascal. No, it's given using Pascal. I think seems like the pseudocodes. And binary search would be easy. And binary search actually you have to put this to array or a list. Binary search can be applied for sorted list, already sorted list, right? Sorted in ID array. This should be sorted to apply binary search or sequential search also we learn. Then the abstract data types. This part we can do quickly because the did they ask about the implementation of this
Implementation of
implementation
what,
code?
sir?
Implementation code did they ask in the exam? Stack queue implementation code.
They just asked us to write a code of stack in Python,
Ah, right. Okay. Then do the implementation too. Right. Okay.
and there were a few questions.
Ah, okay. Right. Let's move to the next one. That is insertion sort. In insertion sort, actually, you virtually divide this list to two things. Do two uh, sections basically. You virtually divide this list to two sections in insertion sort. So see this list. Virtually, it is divided to two lists. Then six here, the in red color one. You have to decide where to insert this. So this blue color list is one list. The red color, this red color one and the white color one is another list. Virtually, you are dividing, right? So six, where to
Yeah.
insert six? Is it before 47 or after 47? Is it before 47 or after 47? Yeah,
Uh, Before 47.
before 47. So insert it to the right
Before.
position. Then the next item is 54. 54, where you are going to insert? Is it before or after 47? Is it before or after?
It'll stay after 47.
After, yes. And there's 17. 17 you have to compare with
Should
54.
be go before.
Before 54. Then compare with 47. Before 47. Compare with 6. After 6. Then it will be inserted again. So you have to compare from reverse order. 93. You have to compare with 54. Yes, it's greater than 54. Insert before that. 28. You compare with 40, 54. Before 40, 54. Even before 47, it will compare with the 17 then. No, after 47. After 17, then will be inserted here. So that is how the sorting happens. The advantage is less number of steps than the bubble sort. Understood? The advantage is less number of
Yes.
steps because you have to just actually you are not stepping blindly. You are not stepping blindly and go to the end. Instead of that, you compare and see which is the right place. After that, you do the stepping on the internet. Stepping actually here, how many steps? The first round, how many steps? First round, how many steps?
Yeah. I mean, one step.
Is it one or two? Yeah, one step. Basically, one step. You just step this. It's one step. The second round, how many steps?
Also one.
Yeah, no steps, no? It remains same. Yeah, this one and this one remain same. No steps.
One.
54 in the 50 same position, 6 in the same position, 47 same position, 17 same position. So no steps. Right? Next round, how many steps? Next round, how many steps? You have to change 54th position, 54 pallad again on one set, 47 pallad again on a second set, 17 again on a third set. There are three steps. Right? You bring 54 down, bring 47 down, and then 17 up. Then three steps. Okay. So that's what has happened.
Okay. I can hear you now, sir. I wasn't able to hear.
Okay. So how many steps in this round? It's three steps. So 40,
Right.
54, and 17 step. Then 47 and 54, 17 step. So likewise, two steps will be there.
Mhm.
Not three steps, it's two, right? 54 and 17 step.
Yeah.
47 and 17 steps, two steps are there. Not three, sorry, two steps. Okay. Now, this has comparatively lesser number of steps and lesser comparison because you are not going to compare everything. You are going to compare only the available items in the new list. So, lesser number of comparisons and comparatively less number of steps. Anyway, rather than saying less number of steps, less complexity, less complexity in sorting. Okay, let's do this. Let's understand this by applying the method practically. So I suggest you a website to do this, right? So you can go to the website. It is called Interactive Python. Interactive, Interactive Python, and then search like
Mhm.
insertion. Sort. And you will go to this site. Um, because this Interactive Python site. Oh, is it not there? Interactive Python, why is not there? There's a website. That's I just remember this website. Wait.
Mhm.
So since it takes time, I'll explain this using Visual Go, right? So I'll go the because there was a site for interactive Python. There's a site, but unfortunately, I'm not getting it now. Maybe they have changed their domain or something
Uh,
else. Maybe okay, but you can use this Visual Go sorting algorithm. Then go to the related algorithm, which is insertion sort, and then click on
mhm.
sort. Then click on sort. Click on go, and you can see okay 38 inserted to the right place, 5 compared with this inserted to the right place, 47 step 1 step 2 step 3 and inserted, 36 step 1 step 2 step 3 and inserted, next one step 1 step 2 step 3 and inserted. So please watch this.
Oh,
So did you load the site? So is it visualgo.net bn
mhm.
slash sorting. So I'll send the link in chat section so you can just know.
All right.
And the next one is so you can see the pseudocode, right? Basically, you can see the pseudocode here. The orange color one is
Oh,
the pseudocode. So orange color one is the pseudocode, not the program code. So, okay, I'll tell you one thing. By looking at this pseudocode, try to compose the Python code. I'll give you some time. By looking at this pseudocode,
Mm-hmm.
right? Can you try to generate the Python code? I'll give you 5 minutes.
Right.
I think you have loaded the site, no? Did you?
No, 1 minute, sir.
Mhm. So please, by looking at this code, try to generate, but don't copy from the internet. That is not good. So you can copy
Yeah.
instantly, but the thing is, so learning algorithm will be easy. So learning algorithm will be the recommended method. It's not easy. It's the recommended method. So you can, so likewise, like I said previously, if I give full code first, then you write down that you won't be able to understand with errors and with constructive methods,
Mm-hmm.
with actually build from scratch. You have to start from the scratch, start from the beginning level because we have not done the bubbles or T1. So you can try for this one. Then you will understand this code very
Right.
well. Right? Just give a try. Right? So that's why I said we learn what to do using this interactive Python one because it shows the
Uh-huh.
similar to this visual go. It shows both code and without the pseudocode, it shows the code and the structure and all these things. That's why I suggested this one. But it's now redirect into this Runstone Academy because I think they have created academy using this. Now, when you go to the library, everything we learned, it's now the interactive way. Those are there as courses or the books, interactive books. So what you
Mm-hmm.
can do is here, this is Python for everybody interactive. You can see that is the one I said, but you have to follow that as a basically TOC and assignment as a course, right? Nested condition recursion functions, and request loops and interactions, iteration streams, files, lists, dictionaries, and tuples, regular expressions, network programming, web services, double OP, and all. So now you can see turtle, then pictures, databases, data visualizing. Likewise, it's now a well organized course, right? So that's what happened.
Right.
Right. But I think let's go to one and see. Let's go to okay. Let's go to one infinite loops. Yeah, it's there. It's there. You can see this, right? Without pain, you can see this. So here, when you go to next, here line by line, you can
Mm-hmm.
just under this is what you ask from me to explain line by line. That can be done. Here it shows. Right? Still, you can use
Oh.
this Runstone Academy site to get it. But so you can see the previous view. Fortunately, due to some extra facilities available in the internet, that is called
Mm-hmm.
what is that? Do you know that? How to see the history? How to go? How to use time machine? Do you know?
Hmm?
Do you know how to use time machine in the internet? Go to history.
No.
Okay, that's a site called archive.org.
Oh, I heard about this.
Yes. So there's in the archive you have time machine, wayback machine. There you can paste the original URL and
Mm-hmm.
since you know the original URL, there was a site like this. Then you can see the time machine. Right? You can see it started in 2012 and going like that. And I just want snapshot in 2019. I just go to 2019 one, and then the green color areas are the caches, web caches. I can see the snapshot of that. Okay, still it's runs down, right? Still it's runs down.
Oh.
Let's go to some history like 2000. But as I remember, it was okay. Let's go to 2018. this is extra, but you should know these things, right? So when you have something,
Yeah.
when you miss something, there should be a way to go back and see. It's 2017. Okay, let's have a snapshot of this. Oh, it's trying to this. It's redirecting now. That side, the domain is now redirecting to the Runstone. So they have
Oh.
set that to redirect. I think even we go to the old side, it will redirect because now itself the thing is the snapshot. So since they have changed the domain, now it's trying to redirect. That's right. Project of Ronstone Interactive. Right, that's right. It's redirecting to the new one. So I don't think that you will be able to visit the last one. But anyway, this service was available, but now it's
Mm-hmm.
like the web caching option. They have programmed they remove the caching option and remove that project to the. Since I think the both domains were available, this is the domain the earlier days. Okay, anyway, it's okay. You can just go to this one and start learning. So you asked about this one, no?
Mm.
What did you ask? It's about which part of the coding
The swapping.
in the insertion sort? Yes.
Swapping.
Okay, you asked about this one swapping. Move
Yes.
sorted element to the right by one.
Right by one. Yes.
Yes, right by one means so that is basically what we did in previous one. The same.
Mm-hmm.
What we did in previous one. The left one should be moved to the right side. That can be done
Yeah.
using the previous bubble sort code that we have used. Is that
So
the thing
temp
you ask?
equal to ml item
Yeah.
that one set.
One of these, right? One of these. Either this one using the temp or this one also possible, right?
Mm-hmm.
One of these. Okay.
Yeah.
Do you need more time or completed?
Uh, I have the the part pieces of the code, but putting them together like for like example for each unsorted elements x, it's we use a for loop and then
Yeah, there is usual for
it
usual
yeah.
things. You have to again use the same thing, but different order and different algorithm.
Yeah.
Different order and different algorithm, different organization. So likewise. Okay, just try, just give a try. I can also do this. So by looking at the code, so make first element as sorted. So how to do that? You can say, okay, you have to mark the element as sorted. Okay, let's say sorted element equal the first element L1 list one zeroth element is sorted. So likewise, then extract the element X for each unsorted element means you have to start from this one, no?
Mm-hmm.
Because the first element is sorted, no? You take first
Yeah.
element as sorted. Then for each unsorted element means this one. So how to write loop for this? You can say yes for okay, let's say element in for element ELM in range for each unsorted element X range length of so 1 2 you have to tell 1 2 1 to length of, why 1 to? Because 0th element is already sorted. 1 to length of L1, you can say like this, 1 to length of L1. So what do you have to do? Extract the element. Extract the element. That means you are extracting the element. So you can say EL, or you can say my extracted element XL. Extracted element is on the one. Technically, you have done the same, right? ELN. You extracted the element. Then for J in last ordered index to 0. What is the last ordered index? 4. Let's use same J in range. Last ordered element. What is the last ordered element index? Yes, yes. Last ordered element is 0, no? Because only one is ordered, no?
Right.
Go to?
Yeah. Yeah.
Yes, 0 down to 0. 0 down to 0 means 0 to 0. And you have to go -1. 0 down to 0, -1. You have to reverse. 0 to 0 or 0 to -1 in Python. Go the reverse. 0 down to 0. If current element is greater than, if current element means, what is the current element? That is the extracted element, this one. Okay. If extracted element is greater than, if extracted element is greater than x plus x. If current, sorry, if current element j, current element j means L1. So I can hear more noises. So what's going on?
What's that?
In your mic, I can hear a lot of noises.
Oh, it's some construction work going, sir. Should I mute my mic?
No, yeah, muting is also okay, but can you reduce the noise? So then, is there any way to reduce the noise? If no way, so it's okay, muting.
I don't think I'll mute it.
If Li, if sorry, L1's, if L1's here current element of J, if J is greater than the x means this element, yes, so extracted element. If it is years, you have to swap. Swapping can be done in this way. You have to swap. If in this condition, you have to swap. Temp means the move the sorted element to right by 1. The sorted element is this one. It's the sorted element SL is 0. And I'm using that sorted element here. The same SL. And I have to move the sorted element to right by 1. So I'm going to assign the sorted element. Temp equal ML sorted element. And ML sorted element is equal ML the sorted element equal the sorted element plus 1. And then sorted element plus 1 is equal to temp. I'm moving that. Then break the loop. Here you have to break if and insert x here. So once done, right, that means this else part, break the loop. So you are going out anyway. and insert that element X there. You can say after moving, yes, after moving, you can input whatever the sorted element index, insert X. Let's do this part and see first, because if I'm going to insert, then will be a problem. So let's print the list here, L1 here, just to get an idea. Right, then this part is not required anymore. Then just run this and see whether this is working according to our algorithm, or is there anything missing. Example of this is actually insertion sort, Python. Okay, so you're not getting anything. Yeah, you have to run this. ML is not defined. What is ML? My list, it's not defined. This is L1. L1 and this is L1. This is also L1. Just run this. Okay, the first round, you can see 45 are here. Don't insert an element. This should be done if current element greater than, current element is 45, it is greater than, if it is greater than, sorry, so this should be done, the swap-in should be done if it is greater than, you have to skip swap-in, right? So I misunderstood this. If it is greater than, so did you understand? Here, okay.
Yes, sir.
Right. So here 38. So let's say extract the element X. The extracted element is 38. Then you check the last sorted element is this one, 1 down to 0. That means here to here you are checking whether this element is greater than that element. 44. 38, is it greater than 44? 38, is it greater than 44?
No.
No. Then do we need to swap? Oh, no swap.
No.
No swap. Just move this while one position to here. You just move one position to the right side. That means what you have to do, in case if it is greater than, 38 is not greater than, right? Here we are checking whether greater than, but we have to check actually whether the list element is the other way, less than. That is similar to this one. If it is less than only, if it is less than the selected element, you do the swap. Otherwise, no swap. So let's run this now. Now you can see the first round. It is so this is like swapping again and again, because so same thing. Anyway, ultimate results will be this, but I don't want to loop through this, right? මේ loop එක ඇතුලේ swap කරන්න නෙවෙයි ඇත්තටම ඕන loop එකෙන් එළියට ඇවිල්ලා swap කරන්න ඕන if it is greater than, so you can keep the same thing. Greater than, you just move the element, move the sorted element to right by 1. If it is greater than, if j is greater than the selected element x, then move the sorted element. Move the sorted element means 44. 44 you have to move right side. So what is right side? You have to take the sorted element, which is 44, current element. So current element, then the sorted element. Sorted element means last sorted element means if it is 23. So let's draw this right in our according to our order 23, 45. Then it's easy to understand. right? So first your sorted element is 23. Your sorted element is 0, it's 23. Then from 1 to end you are doing, okay. Extracted element is 1. Sorted element is 23 and extracted element for Excel is 45. Then you start from sorted element, the 0 to minus 1. 0 to minus 1 means see here, this one. You just check. In the first round, you just check. In the first round, you just check whether J means this. So last sorted element, which is 0, 23, is it greater than the extracted element, which is 45? 23, is it greater than 45? Sorted,
No.
yeah. Sorted element is 23. So this is unclear, sorry. Current element means you are going to sort this, sorry. Sorted element is anyway not greater than 45. You need no need to do anything about that. So this part actually bit ambiguous. So that's why I'm doing with our elements. Right? Let's start from the beginning. SL is 23. That is our sorted element. Then extracted element is 45. That is also clear. Then you run the loop from J to J equal SL. The last sorted element is 0. See here, this loop is 0, minus 1, minus 1. You are going reverse. That means you are only checking this one, 0. 0 means 23. So what you do, you just check, right? You just check here the current element J. Current element J is actually from sorted element. Current element J, last sorted down to 0. That is 0th element. Current element J means sorted element 23. 23 greater than the select greater than this. If it is no, then the first case it's no. Then no need to do anything. No need to do anything, right? Nothing will be done and break the loop and insert X there. Break the loop and insert X there means nothing to do. 45 will remain in the same position. So no SAP. Right here. Then it will come to the second one. After that, it will come to the second one. Second one, then that is where we didn't call. Second one, what will happen? Can you tell what will happen in the second one? Second element. What will happen? The first one is now. So you have to mark this 45 as the next sorted element. After the first round, what you have to do here, swapping process, but nothing to do here. Then after finishing this, what you have to do, sorted element should be now, what is the sorted element? Last SL. Now you have inserted 45 to the right position. 23, 45 to the right position. There's no swapping. Now what is the last sorted element? Did you get my question? So earlier last sorted element is
No.
0th element. Now what is the last sorted element? Yes?
45.
Sorry? So I have
Change
given
sorted.
SL equal SL plus 1 because I have sorted the next element. Now last sorted element is 45. Yes, it's 45. Then you are running this again. Right? Again from yes, each unsorted element is. Then you have to start with each unsorted element. Each unsorted element means this should be the sorted element plus 1. Then you'll get the unsorted element. Get it?
Yeah.
Okay. Sorted element plus 1. So that is the unsorted element. Sorted element plus 1 will be the unsorted element. Then you are telling extracted element will be L1's element. That means the unsorted element is now 2. 2 will be the extracted element. Then you have to compare 2 with from J is selected element. Selected element means this side, this last sorted element. Sorted element is 1, 1 to 0. You are looping through 1 to 0. Okay, may pattern. You are looping through 1 to 0. What you are checking? What you are checking with the 1, that means 45 is greater than 34. Yes or no? 45 greater
Yeah.
than 34. Yes, no?
Yes.
Yes, in yes, what you have to do? You have to do the swapping. How swapping is done? So this is the important point. How swapping is done? Yes.
By comparing the two values.
Yeah, swapping is done basically. You have to move this sorted element to last sorted element means now 45. You have to move 45 one step forward. The last sorted element is SL. SL you have to move one step forward means temp. I'm going to make it temp equal list one. In this list one, the sorted element is the one, and I'm moving that one step forward. Right? That means L1 SL plus 1 is equal to the temp, and then L1 SL will be the temp. Sorry, L1 SL. So this is L1 SL, and SL will be temp will be this one. Temp you are assigning SL. SL plus 1 is, yeah, temp will be SL. Okay. Then for SL you can make SL plus 1, L1, SL plus 1, and for SL plus 1 you can assign temp. Correct or wrong? Temp එකට දාන්න ඕනේ SL. SL ට
Right.
දාන්න SL plus 1 plus 1 එකට temp දාන්න. Okay.
Yeah.
So now let's see. Let's make it short, right? Let's make it short. Let's erase this and let's make it short. Now let's run this. This temp. Let's run this. Okay. What is ln? What is that? Name ln not defined. L1. Okay, now we can see the first round is over. I have to print this, right? I have to print this. Let's print the L1. Now you can see after the first round, L1 is sorted, right? So if there are more elements, so now we have to check whether this works with some more elements. Let's put some other 165 and reapply. Now you can see it's applied, sorted. Let's put some other element. Let's put small element like 4 and apply. Yeah, it's not applied for 4. It's not applying for 4. That's what I said. So you have to always try with different elements. So why it's not applying for 4? You have to think. You have to check why it is not applying for 4. So 23 that was applied, whether it is going for the last element. That's what I'm checking. You have to increase this SL 1 by 1 by 1. I think we are going to miss the last element for some reason. So can we use ln plus 1? It's out of range.
True.
So I think the problem is with the reverse loop, because when you write the reverse loop, I have given -1 in the swapping part. Okay, wait. So now can you understand how you actually find our own error?
Yeah.
And we have to print several, you have to apply printing in several steps and see. So we have swapped sorted element, only the sorted element. Then always it's so when I put SL here, what has
Uh,
when I put sorted element, what has happened? SL, right? That is a damn mistake, right? So I have
mhm.
when we see this was swapped. So yes, it started swapping, but the thing is, it swapped the same element. මේකම එලිමන්ට් එක දෙපැත්තට මාරු කර කර ඉන්නවා හතර පාරක්. So same element swap 4 times, but that is useless. The same position we are swapping. We are not swapping it down. So you have to, after first swap, then you have to swap
Mhm.
these two. After that swap, you have to swap these two. Then these two, if required. So that is actually this J. That is
Yeah.
not SL. So that's why we wrote the algorithm, but we applied them. It's a kind of big mistake in swapping. So you have to identify this. Don't look at the code. So you see during this composition, I never look at any code because
Yeah.
we can correct this according to our algorithm. Only thing is our thinking we have to develop. So if you copy the code from somewhere else,
Mhm.
it's your brain will never develop. You should be able to find, because so we solved a question problem here. So in your question paper, there can be a question. So similar to our mistake, the SLS given, and you got this result. Explain this. Then because this has happened to you also, right? So especially if you are driving, are you driving or not driving?
What's that?
You are doing driving, swimming or driving, anything?
No.
Not both. Riding,
No.
driving, riding, nothing, right? Okay. Anyway, in such, those are practical things, right? Those are practical things. When something
Mhm.
happened to you, when that error comes, you know that this was happened to me. Right?
Mhm.
Again, මොකක් හරි දැන් අපි bike එකක් තියමු. So if you are riding a bike, if you got some issue, suddenly you got an issue, and your friend is asking you, Machan, something happened to my bike. There's some like some noise coming from there. Then you tell that guy, yeah, that can be happened by because the switch might be in the other way. So please check this. How you tell that? Not by looking at some other code, just by your experience. By your experience, you can explain.
Right.
So that's what I am telling. If you got this error, you are lucky. Actually, don't think that you are unlucky. You are lucky because you
Mhm.
got the error. That's why you are worrying, because you saw that how I was worrying. You saw that how I was worrying because I wrote the same algorithm. I wrote the correct algorithm, even according to this pseudocode. And I know this is working, but in some point it's not working. So I was worrying. I was worrying. Then so I have to find a solution to solve this during the given time, because during the class time I can't postpone the class
Mhm.
and tell you that I'll look at this and tell you next day. Can do that, but the thing is, so most of the times, yes, I also used to do that in my earlier teaching life. I'll look at and let you know. But the thing
Mhm.
is, that look at and let you know never happen. Student will also forget, and I will also forget.
Mhm.
And then next day, maybe my solution is
Right.
look in the same thing in the internet and explain you what is there in the internet. So that might be my solution. But by doing that, student will not learn, and I will also not learn. So you have to struggle.
Yeah.
You have to struggle to find solution. Every good things happen from inside, right? So if you give a pressure to egg, it will break from outside and you will lose, it will lose the life.
Mm-hmm.
Right? If you give pressure to the egg
Yeah.
from inside, there will be a new born or new birth. So always give the pressure inside. Don't get pressure. Don't pressure from outside. Don't wait till I pressure you. You get the pressure and then start working. That's what I want to suggest from this example anyway. Right?
Right.
Okay, so
Yeah.
you have to struggle, right? In student life, you have to struggle. In teaching life, also we are struggling. You can see still you are struggling. So,
Mm-hmm.
well, in student life, definitely you have to struggle, and that's the way to learn. Okay. For
Yeah.
today, I'm going to finish from this. We have done two sorts, insertion sort and
Mm-hmm.
bubble sort. Don't buy hard, right? Padang karaganne pa. Don't buy hard. Just understand. Don't buy hard.
Right.
Because buy hard in
Okay.
these things. You can't. I don't think whether can you buy hard all these things. It's not possible. For me, it's not possible. I have very strong
No.
memory. I can't remember all this stuff. According to particular
Mm-hmm.
sequence with the numbers, I don't know. I can't remember this all this stuff. But what I did, I understood the concept. Then it is possible to recreate this.
Yeah.
Okay, let's see in the next day. I'll do 5 day lesson, 5 day class. And do
Mm-hmm.
you have any questions to ask?
Okay.